So in this lesson, we're going to be looking at using un plus 1 equals aun plus b to find convergence or divergence. So you might be thinking, what does convergence or divergence even mean? Well, if you think about it, if you're in you converge, I don't speak Latin, so I can't say it, but con often means come together. Confer, that's another one. Converse, I can't think of any other. Diverge, so it means to go apart. So if you diverge, it means you grow apart. Divide, you know, these are all these break up kind of words at the beginning. So basically, what does it look to converge? You know, if two lines converge, they go like that. And if two lines diverge, they start at some place and then go apart. So diverge, diverge, converge. Okay. So basically what this exercise is about is understanding what causes a linear relation to converge or diverge. Okay, so what does that mean? Well, you know, in the textbook they'd have you go through and type out and work every single little thing out, but I think this is just a clear way of doing it, so I hope you follow along. Okay, so we're asked to set up these different recurrence relations, and we're going to change each one different factor every single time and see how it changes what's going on. So for the first one, we have an initial value of 2, and then we have how much is added each time. Yeah, 2 again is added each time, so it's un plus 2. And all we're going to change is this value in here, the a value, the growth value. So if we change it to 3, how does it change? Oh, it changes quite a bit. You can already see here. I'm actually going to reduce this down to 10 points to make it a bit clearer. Yeah, it's a bit confusing with so many points. Yeah, that's a bit better. Okay, so you can see that, you know, it started off you know, fairly close to 0. You know, started off with 2, then 8, then 26, then 80, then suddenly it just got really, really big. So it's fair to say that this is not converging. This is what we call exponential growth. Okay, and it means that it'll just keep getting bigger. But what about if we change the value to 2? Okay, very similar to before. What about 1? Oh, so with 1, we're not seeing exponential growth, but we are seeing linear growth. We're just seeing it change by the same amount every single time. Okay, so the only growth that's happening is this 2 here, this plus 2 every time. What about if we change the number to something less than 1? So 0.2. Okay, so now we're seeing that although it initially grew, it got to a point where it actually didn't grow anymore. Okay, so it was converging on this solution. What about if we change it to 0.1? Okay, so we see again, it grows, but then it stops. It reaches a place where it can't grow anymore. Why is that? If we try -2, something weird will happen. Yeah, something really weird happens going on here. This does not look like any forms of growing. It's not growing, it's oscillating. So this is a little odd. Well, not what we expect to see. So what about now if we look at changing the value of b? Okay, what's that going to change? So let's set up this equation as before. So this one here now, so 0.3. The initial value is 3, and so the graph looks like this. It's decreasing, but then it actually starts to level off at about 3. It gets to 3 pretty quickly actually, because it is 3 to start with. I'll change this to like 5 for fun. Yeah, I'll change it to 1 actually. Cool. So what's going to happen if we change the value of b? So yeah, like I just did, if you make it 3, what happens? Oh, it's starting to grow then level off. But if I change it to 2, decreases, then levels off. Weird. And then if I change it to 0.2, keeps it the same shape, or 0.1 even, but 0.2, very similar shape again. And what if I do -2? Doesn't change. Okay, so I hope you're starting to get an idea of how the different elements within this equation affect everything it does. So for the last one, I'm going to change this to 0.2, this to 1, and then I'm just going to change the initial amount. So first off, if we have 1, we get an equation that looks like this. And then what about if we change this to 2? Oh, it's changed the other way around. 5. Very similar. What about now? 10. Okay, it's going one direction, but then if I flip this and go -5, oh, we see something completely different. So I'd encourage you to, I'll upload this, just have a play around with it, just see what changing the numbers does, and from that you'll get a much better intuitive understanding of what's actually going on, and it's less guesswork, and it makes solving these problems so much easier if you actually understand what the question is asking rather than just guessing. Okay, enjoy.